Welcome to our demo. This is our whole setup. On my left hand side we have our receiver, and on the right hand side we have the transmitter, and the separation between them is approximately 1.5 meter, as you can see here. Let's inspect the transmitter and receiver closely. So what we have here is the ATmega 328P microcontroller on top of the Arduino Uno board. This is acting as our transmitter. There is no Bluetooth, Wi-Fi module or anything connected to it that can transmit. What we'll do is we'll generate a PWM signal, and corresponding electromagnetic emission will work as our carrier. What we have here though is a transmitter antenna, so basically a bunch of jumper cable connected in series, and we are generating our PWM signal on pin 10, and so we have connected it to pin 10. So that's basically it, and we have this power supply to power the Arduino. Right now it's powered off. I have coded it to generate 4 MHz PWM signal that will also generate 4 MHz electromagnetic emission, and we'll be able to see that on the receiver. But let's check the receiver first closely. So we have our HackerF1 module connected with a telescopic antenna. As you can see here, this is the receiver. We have designed the receiver interface on GNA radio. Currently I can see a strong DC offset at the center. There is a strong interference signal from somewhere, nearly 10 megahertz, and lots of noise and background. If I do max hold, you'll be able to see a bunch of energies here, just the RF background from some sources. What I want you to closely look at is around these 4 megahertz. Yeah, if I can point it. So right now there isn't anything significant there, as you can see, but I have already told that I have programmed my Arduino to generate PWM signal at 4 megahertz, which will generate the emission at 4 megahertz as well. So let's power that up and see what happens on the spectrum. So the Arduino is now connected to power, and if we come here, yeah, you can see that small peak coming up, so at 4 megahertz. So that's the electromagnetic emission that we generated. Now it's not hopping. In next part of the video I'll show you when it hops. This is the second part of the demo. Currently the Arduino is off, but I have programmed it, as you can see it's off, but I have programmed it with frequency hopping to hop at 10 times per second. I have connected it to power brick. That's not on now. I'll turn that on, and you can check out the spectrum what happens. Okay, it's now powered on, and you can see some peaks, small peaks appearing. It actually hops at 16 different carriers. A few of them becomes visible here very slightly, but what's important to note here is that those peaks, for example here at 4 megahertz, is very difficult to distinguish from pre-existing peaks or other noisy peaks. So it's more or less stealthy in that manner. We'll see what happens when we increase the hopping rate. Okay, now the Arduino is powered off, and we're looking at the background spectrum. Just there that DC offset, some interference signal, and some other energies from some sources. I will turn on the Arduino, which is programmed with frequency hopping. It will hop at, currently I have programmed it to hop at 16 different carriers, and at a rate of 10,000 times per second. So let's see what happens when I power on the Arduino. There isn't any major change, and at tiny level there might be something, but it just looks like noise or just some other spurious peaks. So that's our point, that our emission hopping signal is not very obvious. It's actually stealthy in the spectrum, and it just looks like another noisy peak or just another spurious peak.